Welcome back to the video. So this is the part 2. Here the fluid module is open. So first we are going to keep a pressure based transient model here. Let us see how we are going to do it. After the meshing is done, this is the time first setup where we have taken the double precision and processor as 4 already. Now we are going to look how we are going to do the analysis. The model is pressure based and transient. Then in the models, we are going to select a viscous laminar flow and the energy will be off. So going to viscous, click on edit and select the laminar. Click OK. Now go to materials, go to fluid, click on air. Here I am going to keep it very simple. I am going to keep the density as 1 and viscosity as 1, because this is what is going to help us to achieve the Reynolds number 80 which we are desiring. So create and change close. Then we are going to go to the boundary conditions where the inlet should be velocity inlet and the outlet should be pressure outlet. Click on the inlet, wait for it to open. Once the inlet opens, change it to components where the x component velocity will be 100 meters per second, not 1 meter per second. It's going to be 100 meters per second. Apply, close. Check whether the outlet is pressure outlet or not. And then we are going to see the reference values where we are going to change the density to 1 and viscosity to 1. We are going to keep the compute form as inlet, and then we are going to go to the methods where we are going to take a simple method and we are going to keep everything as second order only. Second order implicit, second order append, then least square based method, and if anything is on, just off it. We don't need anything right now. Then go to the report definition. In report definition, we are going to create two reports, lift and drag, for which click on new, force report, drag. Here name it as CD, that is drag coefficient, and click on the cylinder and click on new, force report, lift, change the value as CL, click on cylinder and OK. Now close this. Now go to monitors, click on residual. I'm going to keep all the values as 1E minus 0.6. Now copy this and paste it to x velocity and also continuity. Make sure everything is 1E06. Now you are going to initialize it. I'm going to use the hybrid initialization here and initialize. After the initialization is done, we are going to go for the calculations. Now go to run calculations and change the number of time steps. Here the number of time steps and the time step count is different. That is, if you multiply both, that is 100 into 20, you will get 2000 number of iterations. Okay, so that is the step count. You have to multiply those both. After you change those both, you are going to We'll wait for some time. Yeah, we'll click the data file quantities and we'll select everything and click OK. Now click on calculate and wait for it to run. You can stop the solution after it converges. You can either select at the end of the time step or either you can select at the end of the iteration. Anything is okay. The calculation is running. We'll wait for a bit. Before closing this completely, we are going to open the workbench, click on solution, and we are going to update the solution. This step is must. Now go to results, click on edit, click on Z axis for the front view. Now we are going to create velocity counter, pressure counter, and we are going to visualize velocity vectors. First, counter 1, okay, you can name it there if you want. And the locations, change it to symmetry 1. And then go to velocity variable and click velocity and apply. Now you can see how beautifully the counters have formed. I'm going to increase the percentage of counters. I'm going to make it 100 from 11 so that we can visualize it more smoothly. If you have done a more detailed mesh, if you have more time, you can do a more detailed mesh. While doing that more detailed mesh, make sure that your system is supporting for the larger element size, and you can see it more clearly. You can visualize the effect more clearly, how the air is flowing. Here you can see how the boundary layer is formed. I'm clicking on zoom and I'm going to zoom it for you. So here you can see the formation of air around the cylinder and how the air is flowing and how it's reaching its peak value and how a boundary layer is formed around the surface of the cylinder. Now I'm going to show you the pressure counters. For this pressure, just change it variable to pressure and click apply. Now zoom it. See, you can see the formation of eddies here and where the pressure is maximum and where the pressure is lower. You can see that the contact surface of the cylinder has a greater pressure. Now we will see the velocity vectors. You have to turn off the counters to visualize these vectors. After turning off the counters, at the location select symmetry 1 and apply it. You will see how the velocity vector arrows are there. you will see in which direction the air is flowing. And here in the light blue lines back at the back of this cylinder, you can see the formation of eddies. We can also call it as vortex. So that is for the video. Please like, share and subscribe. Thank you. Let us meet in another video. Bye. If you have anything, comment down.